Okay, so we have a little quiz study guide here, and I'm working over number one. It says the graph shows Ella's activities on her way home from camp one summer day. Write the segment that corresponds with each statement. So she starts here. This is the distance from home and the time. So she's going farther away from home. So she starts at camp. So it must be she walks from camp to the library. So I'm going to go with A right there. So that one's done. Segment B, she spends, now time passes, but the distance to home doesn't pass. That means she's seeing where she is. She's not going anywhere. So she must have spent some time at the library. That is B. And then she's on the move now. It looks like she's going somewhere. And let's see. She goes from the library to Maria's house. So Maria must live closer to home a little bit closer than the library. So that's C right there. And once again, time's going, but she's not going anywhere, staying put. So she must be spending some time at Maria's house. So that's that's D. So D, and she gets a ride home, and that's what's happening here. She just goes from here, and as time passes, she gets closer and closer to home. Distance for home decreases, so that must be E. Okay. On the next one, the data in the table shows speed of a ride at an amusement park at different times in one afternoon. So at time 0, we're at 3:20, or speed 0 is 3:20. So I will do this in red. At 3:20 is speed 0, and at 3:21 is 14. 3:21 is 14, which is right about here. And at 3:22 is 41. So 3:22, 41 looks like it's right about there. And at 3:23 is 62. So 3:23, 62, somewhere around there. 3:24 is 8. 3:24 is a lot less, 8. And 3:25 is back to 0. So that ride must have been over. And I'll connect these because there were speeds in between these. Okay. So true-false statements. The speed increased between 3:20 and 3:22. So 3:20 and 3:22. Yes, it did increase. The speed was going up as time was going, so that would be true. The speed decreased from 3:22 to 3:23. So 3:22 to 3:20. No, it keeps increasing. That's false. Right there. And the time remained the same between 3:23 and 3:25. At 3:23, at 3:23 to 3:25, it didn't stay the same. It just would have been a flat line. And it's not a flat line, so this is false again. I'm going to erase this little random mark. Erase that little random mark I made. And yeah, that's that problem. On this next one, create two-ordered pairs that are solutions to the function, that function right there. At least one member of the domain must be a rational number less than 0. So rational numbers less than 0. Yeah, well, that could be a fraction, like negative 1/2. It could be a decimal, like negative 0.5. It could be negative 1. It could be negative 1. That's a rational number that's less than 0. As long as it's a fraction made of integers, then we're good. So I think I'll go with negative 1 and negative 1/2. I'll go with those two right there. So and it says ordered pairs, the domain. So if you remember, the domain are the x numbers. And rational numbers, I just went over that. And so let's do this. Two ordered pairs. So an ordered pair is this, and has a comma. The domain are the x numbers, so I'll choose negative 1 as a rational number less than 0. And if I have y equals negative 2 plus 3 times that negative 1, That's negative 2 minus 3, which is negative 5. So here's one part of my answer. And then, you know what? I think I'll just, must be a rational number less than 0. I'm guessing that should be good. I mean, maybe I'll just do 1 because I only... So I'll choose my domain number to be domain, which is the same as the x, to be positive 1. So I'll go y equals negative 2 plus 3 times positive 1 this time, which is negative 2 plus 3, which is 1. And so 1. So this right here, this is my answer. Select all on the next one. Select all ordered pairs that satisfy this function right here. So I will go, y equals negative 5 times 0. I want to move this over. Can I do that? Nope. Let me erase this. And I just want to move it over a little bit. So this would be y equals negative 5 times x, which is 0 in this case, plus 2. Do I get 2 for the... So y equals negative 5 times 0 is 0, plus 2, so y equals 2. And that is definitely one of my answers. Boom. Because when I put 0 in right there, I get 2 out, which is that y number right there. Okay, let's do y, oops, I just want to keep it red. So y equals negative 5 times, in this case, negative 2 plus 2. This would be 10 plus 2, which is 12. And this does not work because when I put negative 2 in for x, I get 12 for y, and I'm supposed to be trying to get 10 for y. Let's try this one where 3 is x. So y equals negative 5 times 3 plus 2. This is negative 15 plus 2, which is negative 13, and that works. So that's another choice. And for D, this is y equals negative 5 times negative 10 plus 2. This is 50 plus 2, which is 52. And that's exactly what I was looking for right here. So that is a choice. And then y equals 5 times... Oh, negative 5. Negative 5 times negative 7 plus 2. That's 35. Positive 35 plus 2, which is 37. And that one works as well. I've got a lot of these at work here. I better just make sure that I'm doing negative 5, negative 5, negative 5, negative 5. Yeah, negative 52. That's 35. Okay, just making sure. We don't want to make any mistakes here. And this last one, y equals negative 5 times, in this case, 5 plus 2. That's negative 25 plus 2, which is negative 23, and I would not choose that. So it's A. Choice is A, C, D, E, R, it. All right, number 5. We have complete the table with this function here. So we got to put negative 3 in for x. So it's going to be y is equal to negative 1/3 times x, which is going to be negative 3 in this case, and then plus 2. And when I multiply these, the 3's would cancel, and negative times negative positive, so that's 1 plus 2, which is 3. That's going to be 3. And then I'll put 0 in, y equals negative 1/3 times 0 plus 2. That's just going to be, anything times 0 is 0, plus 2 is going to be 2. So this is 2. And then we have y equals negative 1/3 times 1 in this case, right? Because I got this 1 right here, times 1 plus 2, because that's our function given. And that's what? Anything times 1 is itself. So negative 1/3 plus 2, that would be, 1 2/3. So this is 1 2/3. Don't do decimals for that. Just make it a fraction. That's really easy. And then finally, y equals negative 1/3 times x, which needs to be 3 in this case. 3 plus 2, that would be, what, the 3's canceled, so that's negative 1 plus 2, which is 1. 1. There you go. This part right here is your answer. I'll erase this little arrow here. That's it. And for the last one, which of the following relations represent a function? Select all that apply. This one, when you put 4 in, you get 11 out. You put 4 in, then you get 12 out. Like, what is the rule? It's not following a rule. You don't know, when you have an input, you don't know what the output's going to be. So that's not a function. And basically, when you look at the tables here, we can't have does 53 happen more than one time? Just looking at the inputs. 24 only happens once, 32 happens once, 17 happens once, 45 happens once. So all I care about are these inputs right here. Are they all different? And they are. So this is one of my answers. And again, here the domain is, oh, look at that. I put 1 as an input and I get 4. I put 1 as an input and I get 5. Well, what's it going to be? I know when I put 2 and I get 3 and I get 5, put 5 in I get 17, but here it's inconsistent. So that is not a function. Here, the input, what, 2 you get 3, 2 you get 6. Again, you can have 2 different inputs or domain numbers or x numbers, whatever you want to call it. That's not a function. Our studied, let's see, there's a thing called the vertical line test. So these are the inputs here. Do they repeat any outputs? So no, no, no. There's only one output for that. There's only one output for this. Only one output for that. Only one output for that. Only one output for that. I can't find anything else on the vertical line here that gives me 2 outputs for 1 input. So this is a function. Same thing here. Everything on a vertical line, there's no 2 dots on a vertical line anywhere here. So this is a function as well. Let's see here. All the inputs are different. Okay, that's a function. Here, all the inputs map to its own output. Okay, that's good. And I was just thinking of something, but anyway. So here, vertical line test. I have an input and I have more than one output on that vertical line, so that's not it either. So that is it. I think that what I'm going to do too is I will tell you that let me have one more where if I have input and output, and I have 1, 2, 3, 4, 5, 6, and I have this and this and this, whatever it is. This is so this would be a function too. This is also a function. Because each input has its own output. They may go to the same output, but that's fine. And if I were to put this as ordered pairs, this would be what? 1, 5, and then 2, 5, and then 3, 6. So that's those are ordered pairs that represent a function as well. Everything in the domain is different. It's okay that the range is the same in 2 of these, but not the x numbers of the domain. So the range is the y numbers, and the x numbers are the domain numbers. And domain has to stay different, but the range can be the same. It doesn't matter. And that's it. Thanks for watching.